Okay, for today's lesson, it's going to take place in pretty much two parts. The first part, we're going to look at categorical propositions and really just try and make sense of the various components in the propositions, how they relate to each other, and get some technical terminology for working with them. And the second part is going to stay with the categorical propositions, but we're going to use a visual system of analysis. We're going to go back to roughly fifth grade where you had Venn diagrams where you'd have like sharks and dolphins in two overlapping circles. And you'd say, well, they both have something in common, and that goes in the middle part. And then you'd say, sharks do this, but dolphins don't, so that'd be on one side. And then dolphins do this, and sharks don't, so that'd be on the other side. That system of Venn diagrams that many of you, I think, are familiar with from fifth grade science class is going to help us tremendously with our logical analyses. But that'll be the second part. So let's go ahead and get started with the categorical propositions. A categorical proposition is a proposition or a statement that relates two categories to each other. One category is called a subject term, and the other category is the predicate term. So, for instance, we could say backpacks. All backpacks are bags that go over your shoulders. So backpacks would be one category, and then bags that go over your shoulder would be the second category. The first category, backpacks, would be the subject term, and the second category, bags that go over your shoulder, would be the predicate term. So let's look at a few examples of these. All dogs are canines. Some dogs are poodles. So for the first one, dogs is your first category, your subject term. Canines is your predicate term. Some cats are not tabbies. Some cats are Siamese. No dogs are trucks. No cars are chairs. Some cats are not trees. Some people are smart. And all students are awesome. So these would all be various examples of categorical propositions. And what we can do is really lump these into different groupings. If you notice the first part, you have alls. There's another all one. Then you have nos. And then you have a whole bunch of sums. So we could start by saying, okay, we have all blank are blank. There's one grouping. In the second grouping, you have no blank are blank. The third grouping is some blank are blank. But then if you look closely in the sum statements, a few of them are some blank are blank, but then a few others are some blank are not. There's another, some cats are not trees. So you have some R's and some are not. So we need to account for both of those types of sums. Some blank are not blank. So these are the four types we're going to be dealing with. And this is going to carry us through all of the categorical propositions and the categorical syllogisms. So be sure you're really comfortable with these four groupings of statements. Okay, the four standard categorical statements, we identify shorthand letters to go with them. There's the A form, the E form, the I form, and the O form. In this, you just need to remember that the all S or P, or subject term, predicate term is the S and the P. So all subject term or predicate term, no subject term or predicate term, and so on. Each of those get a shorthand letter. For the all form, it's an A. For the no form, it's an E. For the some are form, it's an I. And for the some are not form, it's an O. And that's going to carry with us for all of categorical propositions and categorical syllogisms. So be sure you have that marked out. Then next, we have fancy component parts for each of these statements. This first part, the all, no, or some, we refer to that as the quantifier. The S, or the first part that goes after the quantifier, stands for the subject term. The R, or the are not, We're going to call that the copula. And finally, the P, or the last part, we're going to refer to as the predicate term. So you have the quantifier, the subject term, the copula, and the predicate term. And that's going to be the way we analyze these for the rest of this section. So what we can do is use these component parts to tell us quite a bit about the categorical propositions. Starting off, so I have on the top right over here on the screen is the slide you saw a couple slides ago that had the A is the all S or P, E is no S or P, I is some S or P, O is some S or not P. On the left, we have, there's a thing called the quantity. And the quantity is either going to be universal or particular. The A and the E forms are universal. The I and the O forms are particular. A word that often helps with understanding the concept of universal is think universal statements make sweeping claims. So when you hear all S or P, all dogs are canines, it's a very sweeping claim. It's talking about every single one. And then if you say something like no dogs are cats, again, that's a very sweeping claim. Of all the dogs, not a single one is a cat. And so the universals think in terms of sweeping claims. That often helps. And then the particulars, the I and the O, you have some S are P, some S are not P. Those are just talking about, a few. And actually in logic, the word some means at least one. So in logic, some means at least one. And so the universals make sweeping claims, and the particulars make, as the name indicates, particular claims. Then you have the quality. The two quality choices are affirmative or negative. The affirmative you could think of in terms of these are inclusive claims. And then the negative you could think of in terms of exclusive claims. So for the affirmatives, you have the A and the I. All S's are P, so there's the inclusive part. All of the S's are inside of the P. And then the I form, some of the S's are inside of the P, so that's including. And then the negatives are the exclusive claims, so none of the S's are P, it's separating the S's away from the P's. And some of the S's are not P's, again, it's separating the S's away from the P's. So quality is affirmative or negative. So you have quantity and quantity being universal or particular, and quality being affirmative or negative. Now, the way we determine whether or not a statement is universal, particular, affirmative, or negative has to do with the component parts within the statement itself. So the quantifier determines the quantity for the A, E, I, O statements. In other words, if you just look at the quantifiers here, all, no, or some, that's going to tell you, just that word alone is going to tell you if it's a universal or particular claim. If it's all, it's making a sweeping claim, universal. No, it's making a sweeping claim, universal. Some, it's making a particular claim, and some again is making a particular claim. And if you continue, the quantifier once again determines the quality for the A and the E statement. So remember, the quality is whether or not it's affirmative or negative. And so this says, if you're looking at the A and the E statement, so the A and the E is all dot 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 are dot dot dot, and the E is no dot 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 are dot dot dot. So the quantifier, the all and the no, determine the quality for these two statements. And the quality is whether or not it's affirmative or negative. Now remember, the affirmative is inclusive, so all blank are blank. Yeah, that's the inclusive one. So this quantifier tells you the quality that the A statement is affirmative. And then the no are is an exclusive claim. So this quantifier tells you that the quality is a negative. So the quantifier determines the quality for the A and the E statements. But if you look at the quantifier for the I and the O form statements, that doesn't help you because they're the same. So sum and sum these are the same words, and so you couldn't just look at the word sum and say, aha, that's an affirmative or that's a negative statement. So for the I and the O form statements, you have to rely on the copula. And the copula is the R or the R naught. And that's going to tell you what the quality is for the I and the O statements. So you have the copula determines the quality for I and O. There's a lot to take in. I'm going to run through this one more time, and then I'm going to switch slides, so be sure to pause it if you want to take a second now. Let me go ahead and run through it one more time, and then I'll tell you when I'm going to change slides. So the quantity is whether or not it's universal or particular. The universals are your A's and your E's. Your particulars are your I's and your O's. The quality tells you whether or not it's affirmative or negative. The affirmatives are A's and I's. Those are the inclusive claims. The negatives are E's and O's. Those are the exclusive claims. The quantifier determines the quantity for A, E, I, and O. The quantifier is the all, no, or some words. The quantifier determines the quality for A and E. The quality is whether or not it's affirmative or negative. And again, the quantifier is the all, no, or some words. And then the copula determines the quality for I and O. The quality is whether or not it's affirmative or negative. The copula is the R or the R naught. And the I is your sum S R P, and your O is sum S R naught P. Okay, I'm going to change slides so we can practice this a little bit. So what we have here is a grid, and what I'd like you to do is just in a second hit pause and fill in where does the A go, where does the E go, where does the I go, and where does the O go. So you have on the top left is going to be affirmative and universal. On the top right is going to be negative and universal. The bottom left is going to be particular and affirmative, and the bottom right is going to be particular and negative. Go ahead and hit pause, and when you got it figured out, go ahead and unpause and I'll write them in. So what you have on the top left, affirmative, you have the A form is affirmative and the I form is affirmative. And then the universals, you have the E is universal and the A is universal. So you want it to be affirmative and universal. That's going to be the A in the top left. So the A form, all SRP, is your universal affirmative. All SRP. Your negative universal, so your universals are your A and E. Your negatives are E and O. So your negative universal is going to be your E form statement. No S R P. Your particular affirmative, so your particulars are your I and your O. Your affirmatives are your A and your I. Your particular affirmative is going to be your I form statement, sum S R P. And by process of elimination, we know that the O form's got to go on the bottom right, but I'll walk through an explanation as well. Your particular negative is your O form. Your particulars are your I and your O. Your negatives are your E and your O. And so there's your O form is a particular and a negative. Sum S R naught P. So there's the four statements laid out in a grid. Okay, let's go ahead and be sure that we know what our component parts are. Here's a statement for us. All green-eyed sloths are slow animals. So question 1, what's the shorthand letter of this first statement? This is an all SRP statement, so it's an A. Question 2, what is the quantity? So the quantity is either universal or particular. Universal is for the sweeping claim, so this quantity is a universal. Second one, what tells you the quantity of this statement? That's going to be, the fancy name for that is quantifier. The word all, but all is the quantifier. Second, what is the quality of this statement? So all are is an inclusive statement, and so that is an affirmative statement. What tells you the quality of this statement? So here it is going to be the quantifier again, because all or no tells you affirmative or negative. So the quantifier tells you the quality for universal statements. What is the predicate term? In this case, the predicate term is slow animals. What is the quantifier? The quantifier is the word all. It's just the first word is the quantifier. And what is the copula? In this case, the copula is are. And the final question, what is the subject term? Here, the subject term is green-eyed sloths. Done. Let's try another one. So, some trees are not good sources of firewood. What is the shorthand letter for this statement? The shorthand letter is some are not is O form statement. What is the quantity? The quantity is going to be particular. What tells you the quantity of this statement? In this case, the quantifier, or the word some, tells you the quantity. What is the quality? So for this one, you have to rely on that word all are not, and that tells you, or those words are not, the copula, and that tells you that this is a negative statement. What tells you the quality of this statement? Just gave that away. It's the copula. What is the predicate term here? The predicate term is going to be good sources of firewood. What is the quantifier? The quantifier is just going to be that first word, some. What is the copula? Got that already. That's are not. And what is the subject term? In this case, the subject term is the word trees. And for kicks, let's go ahead and try one last one. No blue fish are good swimmers. So what is the shorthand letter for this statement? I really encourage you to hit pause as we go through this one to be sure you have it down now. So the shorthand letter for this statement is going to be an E form. What is the quantity? Quantity is going to be universal. What tells you the quantity of this? That's going to be the quantifier. What is the quality? This one's going to be negative. What tells you the quality of this statement? In this case, it's the quantifier again. What is the predicate term? The predicate term here is going to be good swimmers. What is the quantifier? The quantifier here is no. What is the copula? The copula here is are. And what is the subject term? The subject term here is bluefish. Okay, so that's that for these statements. Let's go ahead and see how the quantity quality stuff would work out for changing statements around. So if you had a statement that started off with all SRP and you wanted to change the quality of it, so let's see, if you have all SRP, I'm going to draw that grid up again. So if you have the A form up top left, the E form top right, the I form bottom left, the O form bottom right, this is a different looking picture, but it's just the grid that I did in maybe the third slide in, where it was showing the universal affirmative, universal negative, particular affirmative, particular negative. So up top left you have, it's U for universal affirmative, and then the top right is going to be U for universal and an N for negative. The bottom left is going to be P for particular and affirmative, and the bottom right is going to be particular, P, and negative. So a quality change is going to be a left-right change. So you're going from affirmative to negative or negative to affirmative. And a quantity change is going to be an up-down change. So you have a quality change as a left-right and a quantity change as an up-down. If I change the quality of all SRP, what would the new statement look like? So if your quality is all SRP, you start off with an A form statement and you want to change the quality, so that's a left-right change. You would change it to an E form statement. And so your new statement would read no SRP. And that's going to be the answer for that one. Next, if I change the quantity of some S are not P, what would the new statement look like? So some S are not P, you have A, E, I, O. The some S are not, the are not tells you it's negative, and the sum tells you it's particular, so the particular negative is an O form statement. And changing the quantity, you're going to go from an O form statement up to the E form statement. And so this would say no S R P. All right, that's changing the quantity of the O form. And a last one, if I change the quality and quantity of no SRP, what would the new statement look like? Yikes. So you got your grid, no SRP, E, I, O. The E form statement says no SRP. So you're starting here with your E form statement. The first thing you're asked to do is change the quality. So you'd go from your E to the A, but we're not done yet. Then we want to change the quantity as well. So you'd go from your A to the I. And so the final answer is going to say sum S R P. And that's how you'd play with the quantity and quality of these statements. So this is just asking if you needed, if for some reason you needed to convert the quality or quantity of statements, that's how you would go about doing it. So if I were asked to change the quality of all cats are felines, the quality change would change to no cats are felines. At this point, you're ignoring the truth value of the statement. I know the first one is true and the second one is false. All cats are felines is true. No cats are felines is false. But we're ignoring the truth value and we're just playing with the form of the statement. So everything we did up to this point was just a formal analysis of the statement. Remember, we could do content analysis of the statement. So all cats are green. That, and if I want to say, okay, that's a false statement, that's doing a content analysis, but we're just doing a formal analysis. We're saying, okay, so this is a universal statement, it's an affirmative statement, the quantifier is the word all, the copula is the word are, the quantifier tells us it's universal, the quantifier tells us that it's affirmative, and so we're doing just a formal analysis. We don't care about the truth value of these statements at this point. Later on we will, but right now we don't. Okay, that's the end of this slide, and that's the end of the analysis of the various components of the categorical statements. The next thing we need to do is look at the Venn diagrams or the visual analysis of the statements. So let's go ahead and work on those slides. Okay, so now we're going to work on the Venn diagrams. Venn diagrams are just visual representations of these categorical statements, and we're going to use these visual representations to help us analyze the relationships between various categorical statements. The Venn diagrams have three parts. Part one is going to be where you have the S or the subject term, but no part of the P or the predicate term included. You have space one is going to be the left half of the left circle. And then space two is where both circles intersect each other. And so that's where both circles overlap. They share common property. And then space three is going to be the right half of the right circle. So space one is your subject term, the S, but it's not a P. It's not part of the predicate term. Space two is your subject term and your predicate term where they overlap. And space three is your predicate term, but not part of your subject term. So if you had some dogs are large animals, the left circle is going to be dogs. The right circle is going to be large animals. So for the middle is going to be what's a dog and a large animal. So you could imagine a Great Dane, a husky. Those are going to be dogs that are also large animals. The far left part, so space number 1, is going to be like a toy poodle, a chihuahua, a a shih tzu, those kind of small dogs. And then over on space 3, your large animals, elephants, giraffes, rhinoceros. And once again, space 2 would be your Great Danes, huskies, the big dogs that are, so they are dogs and they're also large animals. So those are the 3 sections of the Venn diagram. Finally, when we use the X in logic for Venn diagrams, that means at least one thing exists here. And in logic, we just say something. So you'll hear me say something a lot. When we say something in logic, we mean at least one thing. And then shading means nothing exists here. So for the example up top of some dogs are large animals, if you want to say some dogs are large animals, you just put an X in the space that are in the middle, which would stand for a dog that is also a large animal. So that X is standing in for your Great Danes and Huskies. If you want to say nothing exists here, then you would use a shaded space. So if we want to say no dogs are airplanes, so you have dogs on the left and airplanes on the right. You want to say no dogs are airplanes. Real, the shading means nothing can exist here. Space 2 in the middle would be a dog that is also an airplane. It would be a dog plane. And we're going to say that doesn't exist, so we got to get rid of that space. So there's no dogs or airplanes. I am shading in that space, and the shading means nothing exists here. So that's how the Venn diagrams work. Let's go ahead and look at a few statements. So for I-form statements, the X is going to go in the middle. That's the overlap. Some dogs are large animals. We did that example. And that's the X just goes in the middle between the subject term and the predicate term. For the E-form statement, that's the other one we did, no dogs are airplanes. So we wanted to get rid of the space where you had an overlap between the dogs and the airplanes. So your subject term is on the left, your predicate term is on the right, and you shade in the middle. For your O-form statement, so this would be some cats are not friendly animals. If you have cats on the left circle, friendly animals on the right circle. Space 1 is a cat that's not a friendly animal. Space 2 is a cat that is a friendly animal. And space 3 is a friendly animal that is not a cat. So space 3 would be like a parakeet or something. It's friendly, but it's not a cat. So if you're saying some cats are not friendly animals, you want it to be over on the cat side, but not part of the friendly animal circle. And so you're going to put an X in space 1. And that's going to be some cats are not friendly animals. So the O-form statement would be represented with X on the left or in space 1. And then the final statement we have is the A-form statement. And that one, you have, if we say all cats are felines, so if we have all cats are felines, so space 1 is a cat that's not a feline, space 2 is a cat that is a feline, and space 3 is a feline that's not a cat, so like a a puma or a leopard or something. And actually here, just to be sure we're all on the same page, all house cats. So all house cats are felines. And so space 1 would be a house cat that's not a feline. Space 2 is a house cat that is a feline. And space 3 is a feline that's not a house cat, like once again a bobcat. So if you have Garfield would be a house cat, but that's got to go in the feline section because this says all house cats are felines. So Garfield would go in the middle, and then pumas and bobcats would go on the right. Space 1 is a house cat that's not a feline, which violates what this statement says. This statement says all house cats are felines. If you're a house cat, you got to be a feline. And so we have to make space 1 disappear. And that's what we're doing for the A form statement, is we're just making space 1 disappear. Now, if you're a house cat, you have to be part of your feline group. And that is what this statement says. It says all house cats are felines. So that's how the A form statement works. And so here is the A form statement. You have the subject term on the left, predicate term on your right, and the shading goes on the left side of the left circle, or in other words, in space 1. All right, let's take a look at all 4 of these now. So if you have the A form up top left, the E form top right, the I form bottom left, and the O form bottom right, the way the shading will always look is for the A form, you'll always shade the left side of the left circle. The E form, you'll always shade the middle section where the 2 circles overlap. The I form, you'll always put an X in the middle. And the O form, you'll always put an X on the left-hand side. This, the way I drew it right here, reflects the grid on, I think, the 3rd slide in, where you have the A on the top left, the E on the top right, the I on the bottom left, and the O on the bottom right. Go ahead and start working on keeping that grid arrangement in your mind. The grid arrangement is going to work for the universal affirmative, universal negative, particular affirmative, particular negative that we learned in the beginning. And then this grid is going to work for the visual system, which we're doing right now with the Venn diagram. So you have A up top left, E top right, I bottom left, O bottom right. Whenever we go into the kind of theoretical discussions, or we're talking about, how's the formal statement look, this grid is what we're going to always rely on and go back to. So be sure you have it memorized according to this grid whenever you're memorizing your Venn diagrams or your universal particular negative, your universal or particular, your affirmative or negatives. And that'll get you a long ways to success in the rest of the section. Okay, that's everything for this section. Go ahead and get working on your homework, and I will see you next class. Take care.